Introduction to hearing sounds. Hearing is a complex process that involves the detection and interpretation of sound waves. Sound is produced by vibrating objects, which create waves of pressure that travel through a medium such as air, water, or solid materials. Our ears are designed to capture these vibrations and convert them into signals that our brain can understand. What are sound waves? Sound waves are longitudinal waves that travel through a medium by compressing and expanding the particles of that medium. These waves consist of alternating high-pressure, compression, and low-pressure, rarefaction, regions. When an object vibrates, it creates a disturbance in the surrounding particles, generating these waves that propagate outward. The journey of sound waves. Sound waves travel from their source through the air and reach our ears. The outer ear, or pinna, collects these waves and directs them into the ear canal. The waves then cause the eardrum to vibrate, which in turn transfers the vibrations to the tiny bones in the middle ear, known as the ossicles, malleus, incus, and stapes. Conversion to electrical signals. The vibrations from the ossicles are transmitted to the cochlea, a spiral-shaped, fluid-filled structure in the inner ear. The cochlea contains thousands of tiny hair cells that convert the vibrations into electrical signals. These signals are then sent through the auditory nerve to the brain, which processes and interprets them as different sounds. The role of frequency and amplitude. The pitch of a sound is determined by its frequency, or the number of vibrations per second. Higher frequencies produce higher pitches, while lower frequencies produce lower pitches. The volume of a sound is determined by its amplitude, or the intensity of the vibrations. Larger amplitudes create louder sounds, while smaller amplitudes result in softer sounds. The perception of sound. Our brains use the information from both ears to locate the direction and distance of a sound. By comparing the time it takes for a sound to reach each ear and the difference in intensity, the brain can determine where the sound is coming from. This ability is crucial for understanding our environment and reacting to potential dangers. The impact of sound on the environment. Sound waves can travel long distances and have various effects on the environment. For example, loud noises can cause disturbances in wildlife, affect human health, and contribute to noise pollution. Understanding how sound waves propagate helps in managing these impacts and designing effective noise control measures. The science of soundproofing. Soundproofing involves reducing the transmission of sound waves between spaces. This can be achieved through various methods, such as using materials that absorb sound, creating barriers that block sound waves, or isolating sources of noise. Proper soundproofing can improve acoustic quality in environments like recording studios, theaters, and offices. The importance of hearing protection. Exposure to loud sounds can damage the sensitive structures in the inner ear, leading to hearing loss. Using hearing protection, such as earplugs or earmuffs, is important in noisy environments to prevent long-term hearing damage. Regular hearing checkups can also help detect and address hearing issues early. Conclusion. Hearing sounds involves a fascinating process where sound waves travel through a medium, are captured by the ear, and converted into electrical signals that the brain interprets. Understanding sound waves and how we hear helps in appreciating the complexity of our auditory system, managing environmental noise, and protecting our hearing health.